Hello everyone, welcome to MyDBOps open source database Meetup16 recorded live in Bangalore. MyDBOps excels in open source database management, offering tailored solutions for MySQL, MariaDB, MongoDB, Postgres, TiDB, Cassandra, and more. MyDBOps organizes meetups to facilitate knowledge sharing, networking, and collaboration among professionals in the field of open source database management. Coming back to the recording, MyDBOps was thrilled to present Sreedharma Vijayan, India Director at PingCAP, who presented on how digital industries can leverage TiDB, a modern distributed database, to manage the exponential growth of data. He explored how TiDB overcomes scaling limitations and performance bottlenecks faced with traditional databases. Without further ado, let's dive into the recording of Sreedharma Vijayan's insightful presentation.
So my name is Sreedharma. I just joined PingCAP a year back. I was with AWS for 6.5 years, and before that I was in Microsoft for 11 years. So I've been in the industry for some time. I'm mostly in sales. Okay, I'm a sales guy. Okay, but I manage the India business for TiDB. So last year I joined TiDB to take over the India business. So that's why I'm here. So the agenda for this is basically to let you know what is TiDB. So I saw a couple of hands raised, right? You might know what is TiDB. Then what are the benefits? Then we also look at the vector offering which we have currently from TiDB. So here we are looking at the different types of users who are there and what are the challenges that they are facing. Okay. So I will go with the user profile and what are the challenges, and then we look at how TiDB addresses that. Okay. So if you are a database administrator or if you are a technology decision maker, what are the kind of challenges that you're facing currently? So you may have a lot of questions, like how can my database scale out in situations where see now, if you see the e-commerce situation or any other platform, the data size, the number of users are humongous, right? The hits are maximum. So if you see how can a database grow, as the user inputs coming, your user requests come in, right? And how can you elastically scale the database? Which means, say we have customer Flipkart is our customer. So what happens usually is that during afternoons there is a spike. And evenings they have a spike because usually people buy stuff based on that. So how can we address the elastic requirements? Which means, whether at that time we'll increase the database, number of databases and decrease it, scale out. Okay. So when you're looking at a single node architecture, this is usually the situation, right? So what happens is that when you have one single server architecture, when there is more load coming in, you will keep on adding the processing power. Maybe you'll increase the RAM, maybe you'll increase the processor. So what happens then is that it leads to a limitation of the physical hardware. Then the second option is adding more servers. When you're adding more servers, it requires sharding. The sharding is complex, right? It requires its own skill set for administrator. So these are the two different challenges that comes up when the users come in more. So this is a real-time situation, which is actually Flipkart situation only. If you see, they started with one master server and a hot standby for backup and a read replica. So they wanted a read replica so that it won't hit the master server with all the read. So the master server will be able to serve the write request faster. Then they kept on moving into 5 shards. Then they wanted a DR site, which was another. So this, how it expanded is like this. So that's when TiDB came in. And then the second set of user is a business analyst. So what his challenges are a little different. He wants to have an analytical view of the transactions which are happening. Like if you see delivery, one of our customers, they actually track where the shipment is going, which trucks are free. They are taking the daily transactional analytics and showing it. They want to display it to the customer where their trucks are, when it will reach, whether it will reach on time. Okay, so these are the challenges which are there. So they need transactional analytics to be shown, and currently these are all different systems, right? So that's what we have built TiDB. TiDB is basically a HTAP server, which includes both OLTP and OLAP. So you can have analytical workloads as well as OLTP databases running in it. And as the name suggests, right, it's titanium database. That's called TiDB. Okay. So we are one of the fastest growing databases in the world now. Some of the customers that we have is like LinkedIn. So recently we had LinkedIn as our customer. So that itself shows that the kind of, as the user base grows, there is a requirement for a very stable database. And we had some major competition for that. Okay, we had Cockroach DB, and almost all DBs were there competing with us. But finally they decided going, and it'll be a public reference very soon. So what are the benefits of TiDB? TiDB has got horizontal scaling with automatic sharding. Okay, so there is no manual sharding in this when you're horizontally scaling. Then it is highly available because TiDB setup itself runs on 3 servers, and the data is shared between 3 availability zones. And if one zone goes down, the other 2 will take up. Okay. Then you can run mixed workloads. That's what I said, right? You can have transactional as well as analytical data sitting inside the same database. You don't need a different database for that. And it is MySQL compatible. It doesn't mean that we are built on MySQL, but we can follow all the MySQL codes running. And we also run on multi-cloud. We run on AWS, GCP, and we are currently working with Azure to have a DBaaS in there. And basically we are an open source company. So whatever the features that we show here, it's all available free. Okay. Then if you want the enterprise edition, that is the paid version which you have. Otherwise, any feature that we say, we didn't want to keep anything as enterprise or which is not there in the open source edition. So currently we have the open source edition which anybody can download. Then we have TiDB Cloud, which is the cloud version. That is also free. If you go to tidbcloud.com, you can create an account. You can have a database up and running in say, a matter of 2-3 minutes. Okay. Then we have the on-premise one, which is the enterprise edition, which can be hosted on a virtual machine or on your own physical servers or on an EC2 instance or any of the VMs on cloud. So these are the 4 available. Actually, one is open source. Definitely you should try it. It's free. There are many customers who are using, some big names are using still now, okay? They are not more like Razorpay, okay? Razorpay has still been using TiDB for some time now. So we are currently on version 8.1, okay? We have come out with a new version. But at the heart of it, we are always open source because when we started, our founders, 3 of them were actually developers, and they faced a lot of challenges on the regular day-to-day issues. So they wanted to create a product which will at least try to sort some of the problems that they faced. So that's why they created this, and they put it on open source. And we got the feedback from the community, updates, patches. Still we work, and we got one of the highest ratings in GitHub. Okay, GitHub we have the highest ratings. So we are basically an open source company, and we also have end-to-end encryption built in on the fly and at rest. Okay. So I was telling about data, right? What happens if data goes up? So when you're scaling out, suppose it is a 10 GB currently, and you have 6 servers. When the data goes up, right? You can scale out easily by adding nodes here, and performance increases linearly. Okay, it's not like one shot will increase. So based on your cluster, so you can keep on adding servers, and this is for scaling out. Okay. When you're talking about, but what about the short-term surges and dips that I said, right? In certain cases, there will be dips and then sudden spike will be there in the afternoon. What will happen to that? So if you look at this, TiDB can automatically scale up and scale down. Okay. So what happens when the load is increasing, the number of servers are increasing. And at this peak, right, it has got some 7 servers currently. Then as the load goes down, it will reduce the number of servers. This actually, it is publicly available in a demo. Okay, so what we've done is that we have created, it is playbook at playbook.tidbcloud.com. You can go there. We have created 2 sets of similar MySQL-based databases. One is running on AWS, RDS MySQL. one is running on TiDB. So you can see the performance there. This, whatever I'm saying, we can show it directly there. It's running, it's running on AWS. And our database is running on AWS itself. So there is no this thing. So you can check out. I can show that at the end if we have time. Okay. And this is one of the use cases that we have from Flipkart. They had a project to check 1 million QPS, okay, at a latency less than 8, but they cracked it, and they also saved around 82% of the servers. They reduced the number of servers. This is the public side. We didn't put it. It is there. It has been put by a Flipkart technology guy itself. It is available online. Okay. So what do you mean by TiDB is highly available, right? Highly available means at the beginning itself, our servers are distributed across 3 availability zones. That is the architecture. Which means if you see there are 3 availability zones, and it is based on Raft protocol. It is automatically replicated between these 3 availability zones. So what happens if one fails? The other 2 will take up. Then when the new server, if you're adding, so this is gone, if you're adding the new server, it automatically heal the new server and bring it up without any muss. So your data is always safe. Okay. And TiDB also, as I said, we have creatively mixed both analytical and transactional workloads into this, which means you can run both in the same. Basically, it's columnar and row-based data which reside in the same server. And so how it benefits is that you can take the analytical reports from the same server. So you need 2 different servers with 0 lag. Okay. So here is what our architecture looks like. We got 4 layers, so 3 layers basically. The TiDB layer is the processing layer where all the computing happens. Then we have PD, which is basically the metadata, which is the brain of TiDB. Then we have TiKV and TiFlash. So TiKV is the storage for columnar data, so for row data. And we have TiFlash as well for analytics. So TiFlash is not by default it's enabled, but all these things, right? It's available as open source, okay, as well as in the premium, in the enterprise edition. So TiDB is where the first hit happens. When any MySQL code or a DB attach, it comes there, and then it stores in TiKV. TiKV is basically a key value storage. It stores the data there, and so as I said, data is spread between 3 servers, right? So where it is stored, the PD has got the information. What happens is that the next time where the region is there, the PD will have the information on that. And if you see TiFlash is basically for the analytical workload. That's why I put it in dim. But there are customers who use that extensively as well. And we also have compliance requirements which we meet. We have ISO 27001, 27701, and SOC compliant, HIPAA compliant, and we have GDPR compliant as well. Because most of the customers are from the finance sector, and we're currently getting into the healthcare sector as well, because the outsourcing of healthcare data is something which is the new trend which is happening, which we are seeing across. Because all the health checkup data, ECG, scanning reports, they want something to act which is faster. This is something which happened in a year. Okay, the trend which is coming up. So it's actually outsourcing the healthcare data to a vendor rather than having it internally for hospitals. That can be a good thing because you can share it with multiple people. Wherever they go, they can just access it from the cloud. It's a good thing. So we are HIPAA compliant as well. And we are available on both. Currently, we are available on AWS and GCP. We are available on GCP and AWS as a marketplace product. You can just buy with one click. You can buy it from the AWS or GCP. And we also have on-premise one, which you can run it on your own servers, or you can run it on AC2 instance as well. Okay. So when you go into, TiDB is basically, it can be configured as a vector database as well. Okay. So when you're talking about vector, we should go back into history and see how it has evolved, right? First, they were SQL database, which stored structured database in tables. Then came NoSQL with unstructured data, which will be stored, which was stored in documents, right? And this was one big hit, right? Because when the web applications came in, the real-time web applications came in, a lot of people were using NoSQL, right? Then with the advent of mobile, GraphDB came in, which stored data in nodes. Then the last iteration is VectorDB. So VectorDB stores, it can store all of this, okay? It can store documents, it can store images, it can store almost everything, right? Audio files. So what it does is that it converts into a numerical value, and that numerical value is stored on the database. And then what is the use of this numerical value, right? So when you have numerical value, multiple, say that case of Apple, okay? Apple, if you set a numerical value of 1, but Apple can be a fruit, it can be a phone, it can be a stock as well, right? So when you're looking at comparing, so somebody types in ChatGPT. ChatGPT is the biggest example for this, right? Because it has got a VectorDB running behind. So if somebody types, which stock I can compare with Apple, it should not go and search Apple as a fruit or orange, So it should look at similar patterns. So that's when the vector has got vector embedding, which does similar kind of grouping that they do for all the vector database. So in normal situations, we'll have to have a separate database which for vector, but not in the case of TiDB. TiDB you can use the same server as a vector database because we are a vector database compliant. I'll show you how the architecture of it. Okay. So the vector is basically an array of numerical numbers. Every data that you put in, a file you put in, a document you put in, it has got a number. Okay, and embedding is like similar pattern, like as I said, Apple as a stock and Apple as a fruit. We'll have similar grouping of these vectors, which is put together when you're doing search. Okay. And what are the use cases? Best use cases, as I said, it's the chatbots, which is ChatGPT. So ChatGPT basically behind the scenes, it has got its own, then it is growing as well. So the database has to be that efficient to store all the data that comes in. There are some times when we put in new query, where it goes in stores, right? So you can have the vector database stores that as well. So what are the benefits of vector database? First, it can take any type of data and convert it into numerical value and store it, right? Then scalability. As I said, ChatGPT is the biggest example where the storage is unending, right? You'll keep on, somebody will be putting new queries every day. So it's also learning inside it. Where it will learn, it will create an array for that, and it will compare these arrays in future so that it will give recommendation, right? Then speed and performance. So since TiDB also has got indexing features, which it will automatically index all the latest queries which come. So the speed and performance is also there in a vector database. This is the common traits of any vector database. You can not only TiDB. Okay. So as I said, like documents, the embedding model will be. This will be the kind of data which will be stored. Say 03 or 07, a number. Images also will be like that. And based on that record, it will whenever search comes in, it will look at that number 1, a number 0.3 or 0.1, and show the data. And as you know, we are AI compliant, which vector database is built into us. So what it is used for? So going forward, what happens is that the recommendation engine which comes in. When you have humongous data, so as I said, Apple, Samsung, maybe, but phone, stock. So the recommendation engine, like if you see Flipkart, somebody is searching for a phone, and it will show all the recommendations of the phone, which was the common numerical value for phones. The common numerical value for phones, it will take only that and show that. So it will give recommendations as well. Okay, and large natural language processing, it stores all the latest, all the data it stores there. Especially it can classify documents, images, everything it looks for, and the data keeps on growing in NLP, right? And the third situation that we have seen is from finance side is from the fraud detection. There are certain patterns which usually, frauds use, right? You might be forging signature, maybe putting a fake Aadhaar card. There are certain patterns which with AI you can understand that these patterns usually is seen in somebody who's trying to fraud the system. So those kind of patterns, it keeps on learning. So any similar pattern which comes in, it will automatically detect and give warning. Okay. So these are the 3 use cases currently that we have seen. And if you see, if you want any other database to run vector data, you need to have a vector database by itself because the data, it requires faster access, right? So you'll create a separate vector database, and the daily transaction like the query, everything, we'll have a transactional database, which will be working with each other. But for TiDB, there is only one server. You don't need multiple server configuration. It's a very simple architecture because it is vector enabled. And we have TiDB serverless with AI search coming in, which will be released in, I think, in a day or 2, where you can incorporate direct search, based into all this, the embedding that we've done. So that is enabled by default now. And these are all our customers that we have. We have Airbnb, we have LinkedIn, we have Pinterest. Any company which has got more data than 1 TB, definitely TiDB's performance, shows up there big time. Flipkart, Databricks, PayPay. These are the list of customers that we have. And there are a lot of customers who are on open source, which we also don't know. Okay? People can download and they can use it. Recently, we came to know that government of Bangladesh's entire government project is running on TiDB. I reached out to a couple of people, then I realized that these are the customers which is there. Then Nepal government, okay, they are using TiDB for a year. All the government payment is run using TiDB, open source again, because we cannot do anything, right? We cannot take data from open source, right? We cannot tell that, oh, this is the customer to convert to commercial. But we are happy that a lot of customers are using, which we never knew that they were using that. And we have been named in 2024 Gartner report as the customer's choice for cloud database. Okay, that's a big recommendation for a startup like us, right? We're not like a big company, we're a small startup here. But the customer names doesn't show that, but still, it's a great thing for us. We named as the Gartner customer's choice for the cloud DBs. And this is TiDB serverless. So we have serverless as well, which can go to tidbcloud.com. You can spin up a free instance, do entire testing. It will be there forever.
Thank you for joining us for this insightful session from MyDBOps Open Source Database Meetup 16. We hope you found Sreedharma Vijayan's presentation on the intersection of distributed databases and AI valuable. We will be releasing videos featuring our next speaker soon. Stay connected with us by subscribing to our channel. For more informative content, we invite you to join us at our next event to continue learning and networking with professionals in the field of open source database management.